Welcome to the solution of GET 2021 AC Signals and Systems question number 41. Consider the signals x of n is equal to 2 to the power n minus 1, u of minus n plus 2, and y of n is equal to 2 to the power minus n plus 2, u of n plus 1, where u of n is the unit step sequence. And let capital X of e to the power j omega and capital Y of e to the power j omega be the discrete time Fourier transform of x of n and y of n respectively. Then what is the value of the integral 1 by twice pi integration of 0 to twice pi capital X of e to the power j omega capital Y of e to the power minus j omega d omega? And the reference to this question can be found in Principles of Signals and Systems, Week 11, Lecture 63 to 68 by Professor Aditya K. Jagannatham. And let us look at some of the useful data, which includes the formula for the DTFT of a given discrete time signal x of n and the inverse discrete time Fourier transform formula. And this is given in useful data number 1 and 2. There is a DTFT of a discrete time signal x of n is given by capital X of e to the power j omega is equal to summation of n is equal to minus infinity to infinity x of n e to the power minus j omega n. And the inverse discrete time Fourier transform is given by x of n is equal to 1 by twice pi integration of 0 to twice pi capital X of e to the power j omega e of e to the power j omega n d omega. And the third thing is that the convolution in the time domain is equal to the multiplication in the frequency domain. And finally, the time reversal property of the DTFT of a discrete time signal x of n, which says that if capital X of e to the power j omega is the DTFT of x of n, then the DTFT of x of minus n will be equal to capital X of e to the power minus j omega. So first, let us look at the given question. The given question is to find integral 1 by twice pi integration of 0 to twice pi x of e to the power j omega y of e to the power minus j omega d omega, where we are given x of n is equal to 2 to the power n minus 1 u of 2 to the power x of n is equal to 2 to the power n minus 1 u of minus n plus 2 minus n plus 2 and y of n is equal to 2 to the power minus n plus 2 u of n plus 1 2 to the power minus n plus 2 u of n plus 1. So these are the two given signals, and we need to compute capital X of e to the power j omega and y of e to the power minus j omega, where x of e to the power j omega and capital Y of e to the power minus j omega are the discrete time Fourier transforms of these signals, right? A discrete time Fourier transform of x of n and y of n. So if we denote x of e to the power j omega and capital Y of e to the power minus j omega by some p of e to the power j omega, then what is the inverse discrete time Fourier transform of p of e to the power j omega, which is denoted by p of n is equal to 1 by twice pi integration of 0 to twice pi capital P of e to the power j omega e to the power j omega n d omega. So this is the formula for the inverse discrete time Fourier transform. And substitute the value of P of e to the power j omega 1 by twice pi integration of 0 to twice pi capital X of e to the power j omega capital Y of e to the power minus j omega e to the power j omega n d omega. And what is the value of P of 0? P of 0 will be equal to 1 by twice pi integration of 0 to twice pi x of e to the power j omega y of e to the power minus j omega, and this term will be equal to 1, and therefore P of 0 is given by this. Now if you look at the given question, is to compute this integral 1 by twice pi, integration of 0 to twice pi, capital X of e to the power j omega, capital Y of e to the power minus j omega d omega, and p of 0 is given by the same integral, and therefore the question is to compute p of 0. Right, so let us compute p of 0, and p of 0, p of e to the power j omega is the multiplication of x of e to the power j omega and y of e to the power minus j omega, which in the time domain is equal to the convolution of, so I'm writing it here, in the time domain p of n will be equal to the convolution of x of n and y of minus n, right? And for any two given signal x of n and z of n, what is the convolution? The convolution formula is given by summation of k is equal to minus infinity to infinity x of k, z of n minus k, correct? So let us write down the convolution of x of n and y of minus n. X of n is, it will be summation of k is equal to minus infinity to infinity x of k, which is 2 to the power k minus 1, u of minus k plus 2, minus k plus 2, and y of n will be y of minus, so y of minus n will be, I will write it down here, y of minus n is equal to 2 to the power n plus 2 and u of minus n plus 1, right? This is y of minus n, and therefore you substitute n for n minus k, and that will be 2 to the power n minus k plus 2, n minus k plus 2, u of minus n minus k, minus n plus k plus 1, right? So you substitute the value of n is equal to n minus k in this equation y of minus n. So this is the expression for p of n, and which we can summarize as summation of k is equal to minus n infinity to infinity 2 to the power k minus 1 plus n minus k plus 2 and u of minus k plus 2, u of minus n plus k plus 1, and this is given by summation of k is equal to minus infinity to infinity, the k is cancelled out and we get 2 to the power minus 1 plus n plus 2, u of minus k plus 2, u of minus n plus k plus 1. Now let us look at this signal u of minus k plus 2. U of minus k plus 2 is, so u of k is from 0 to infinity, it will be equal to 1, right? U of k, and what will be u of minus k? U of minus k will be from minus infinity to 0, and this is u of k, this is u of minus k, and what will be u of minus k plus 2? It will be shifted to the right, and this will be u of minus k plus 2. So this signal will be equal to 1 from minus infinity to k, line between minus infinity to plus 2. And therefore we can change this expression now. We can change the limit for k, that is k is equal to minus infinity to 2 and 2 to the power minus 1 plus n plus 2, and this will be equal to 1, and therefore we are left with minus n plus k plus 1. So I'm writing down here again, p of n is equal to summation of k is equal to minus infinity to 2 to the power minus 2 to the power n plus 1, I can write 2 to the power n plus 1, u of minus n plus k plus 1, minus u of minus n plus k plus 1. Okay. Now let us find p of 0, which is given by summation of k is equal to minus infinity to 2, and this will be 2, and this will be u of k plus 1. And now again let us look at what is this u of k plus 1. This is valid from k is equal to 1 for k lying between minus 1 to infinity, right? And therefore p of 0 will be equal to summation of k is equal to minus 1 to 2 for 2 and u of k plus 1. So it will be 2 into, so if you let us write it down here, k of 0 plus u of 0 plus u of k is equal to minus 1 is u of 0, k is equal to 0 is 1, two, and u of 3, right? And this will be equal to 1 1 1 1, and this is 2 into 4 is equal to 8. So p of 0 we get the value is equal to 8, right? So the final answer is p of 0 is equal to 8. P of 0 is equal to 8, and therefore this integration will be equal to 8. Understood, right? So we get the p of value for p of 0 is equal to 8, and p of 0 is nothing but p of 0 is the 1 by twice pi integration of 0 to twice pi capital X of e to power j omega capital Y of e to power minus j omega d omega, and therefore the solution is this will be equal to 8, right? Thank you.